What are the key properties of all quadrilaterals? Imagine a shape with four straight sides that always comes back to where it started. That shape is called a quadrilateral, a simple yet fascinating two-dimensional figure. No matter what kind of quadrilateral it is, it shares some basic properties that make it unique among shapes. First, every quadrilateral has four sides and four corners, which are called vertices. These sides can be all different lengths or some equal, but they always add up to form a closed shape. One important fact is that the total of all the interior angles inside any quadrilateral always equals 360 degrees. That means if you add up the four angles, you will get exactly 360 degrees, no matter what shape it is. Another key property involves diagonals. A diagonal is a line drawn from one vertex to the opposite vertex. Every quadrilateral has exactly two diagonals, and these diagonals always cross inside the shape. If you draw one diagonal, it divides the shape into two triangles. This is true for all quadrilaterals and helps us understand their structure better. When you look at the outside of a quadrilateral, the exterior angles also follow a rule. The sum of all four exterior angles, one at each vertex, always adds up to 360 degrees. Adjacent sides, which are sides that share a common vertex, always meet at a corner. Opposite sides, which do not touch, are across from each other. The angles that are next to each other, called adjacent angles, share a side, while the opposite angles are across from each other. These properties stay the same no matter what kind of quadrilateral you are looking at. Knowing these basic facts helps when studying special types of quadrilaterals like squares, rectangles, parallelograms, rhombuses, or trapezoids. For example, a rectangle has four right angles and opposite sides that are equal and parallel. A square has all sides equal, for right angles, and diagonals that cross at right angles. Recognizing these common properties makes it easier to understand how different quadrilaterals behave and how to solve problems involving their area, perimeter, or angles. These facts form the foundation for exploring more complex shapes and their properties in geometry.